All right, guys, in this video, we're going to look at percent yield, actual yield, and a theoretical yield, and how they are all put together. All right, so hopefully you've already watched much of the overview video, right? Some things that you should have picked up there, or that you might have picked up in the reading if you've done the reading. The theoretical yield is only true in theory. And what I mean by that is, in reality, all of the atoms in a flask are not going to react with each other. There's never 100% complete reaction. Because of that, we would expect, if we actually ran an experiment in the lab, that the theoretical yield should be greater than the actual yield that we produce. If you get an actual yield that's greater than the theoretical yield, then more than likely you have a contaminated product. We usually just call that dirty. So we would say your product is dirty. That's how we would describe that. When we find percent yield, that tells us how far above or below we are. Now, here's the formula. Percent yield is actual yield divided by theoretical yield times 100. Now, this is an absolute value, okay? It would not be wrong to put absolute value bars there. But I like to keep the positive and the negative, and here's why. If you get a positive 9.2% yield, well, that tells me that you overshot and you're likely dirty. You probably have a contaminated product. On the other hand, if you're 9.2% yield and it's low, well, that tells me that you're under, right? You're under the theoretical yield. You might not be dirty. It could be pure, right? It's worth running a test to see if it's pure. If you're over, you know it's not pure. But if you're under, it could be a pure product and we should test it. So actual yield always comes from the lab, and a yield is a mass, all right? So anytime you see yield, we're thinking mass, probably going to be using grams, okay? Actual yield always comes from the lab. You find it with a scale. And the theoretical yield is always found mathematically, and we've done that in some other videos, right? We convert our reactants to our products. We see which one makes the lowest amount. It's tied to the limiting reactant, all that good stuff. Now, these are practice problems. It's a practice problem video. So again, you should pause the video, work the problem, and see if you get it right afterwards, right? So watch the explanation after you try to solve it. You're going to need your periodic table, your calculator, and some scratch paper to do this. So let's look at the first one, all right? Again, pause it, try to figure it out on your own, and then give it a go. So here we are. Chlorine forms from the reaction of hydrochloric acid with manganese 4 oxide in the following equation. So they gave us an equation up top. It's balanced. We're good. If 50 grams of hydrochloric acid and 86 grams of the manganese salt react to form 20 grams of chlorine, what is the percent yield? All right. So a couple things about this problem. First, we know that we have 50 grams of hydrochloric acid. We have 86 grams of our manganese salt. We know that we're making 20 grams of chlorine. We can ignore the water and the manganese chloride that are formed. All we need is this product and obviously the two reactants. This was actually made. So this is an actually made, right? This is our actual yield. So we know AY, right? AY is 20.0 grams of Cl2. It asked us to find percent yield, right? We need to know the percent yield based on the question there. So we know percent yield equals AY over TY times 100. So the only thing we need to find, because we know AY, we have that, right? We need to find theoretical yield. And we already know how to find theoretical yield, right? We've done that before. So I'm going to get rid of some of these marks. I'm going to put the ones back up there that we're going to use. So we need 86 grams. We have 50 grams. And over here we have 20 grams. And we can ignore those. All right? So let's figure out the theoretical yield. Give it just a second. So 50 grams HCl. Hydrogen plus chlorine gives us 36.461 grams of HCl in a mole. By the way, I know this is a 3-bracket problem because we're going grams to grams. We have 4 moles of HCl in our problem. Gives us 1 mole of Cl2. And 1 mole of Cl2 has a mass of 70.906 grams. There we go. All right, we're also going to need to do the same thing with manganese 4 oxide, MnO2. So MnO2 is 86.936 grams. All right, we just take the periodic table, 2 oxygens and a manganese, add them together. All right, we've got a 1-to-1 ratio according to our balanced equation. Right. The balanced coefficients are 1 and 1. And then again, we're converting to moles of Cl2, which is 70.906 grams of Cl2. All right, so this is how we figure out our theoretical yield. So let's see what we get here. We've got 50 divided by 36.461 divided by 4 times 70.906. That gives us up top 24.31 grams of Cl2. All right. Now, at the bottom, hopefully you can tell that the top number here is probably going to be our theoretical yield, but let's just run it in case. So 86 divided by 86.936 times 70.906 should be around 70. Yep. 70.14 grams of Cl2. So this is our theoretical yield. That's not what the question asked for, right? The question asked for percent yield. So now that we have our theoretical yield, we have AY in the problem. So we know that percent yield equals 20 grams of Cl2 divided by 24.31 grams of Cl2 times 100, and that's going to be an 82.27% yield, and there's our final answer. So we're still using some of those skills from limiting reactant theoretical yield, but now we're using it to find percent yields. We could also, and we'll see this in, I think, the third problem, use it to find one of the AYs or TYs if we knew the other variables, right? Just using some algebra. So there's our first problem. All right, here's our second one, the production of ethanol by fermentation. So alcohol is a solution in chemistry, right? Here we go. Ethanol is produced from the fermentation of sucrose, so that's table sugar, in the presence of enzymes by the following equation. There we have it. It's already balanced. It's good for us. We have 684 grams of sucrose is fermented and produces 349 grams of ethanol. What is the percent yield? So we got our still running, and there we go. Now, they don't tell you what the chemicals are up here in this equation. Hopefully, you can identify from reading that the sucrose is sucrose is a reactant, and this must be the ethanol because we know carbon dioxide, we know water. So that's important, right? We know that we have 684 grams of our sucrose, and we know that we're going to end up producing 349 grams of our ethanol. Now, the interesting thing here is we don't have two different reactant amounts, so we're not trying to determine who the limiting reactant is here. It's telling us, hey, it's the sugar. So all we need to do is convert sugar to ethanol, and that will give us our theoretical yield, and then we can find percent yield just like we did a moment ago. So let's do that. 684 grams of our C12H22O11. I'm just going to write that as sucrose down here on the bottom. You add all that up, it's 342.297 grams per mole. So there's sucrose. 1 mole sucrose. I might should have given myself a little more room. According to our equation up here, it takes 1 mole of sucrose to produce 4 moles of our C2H5OH. By the way, anything that ends with OH in organic chemistry is an alcohol, just fun fact. And 1 mole of our ethanol is 46.069 grams of ethanol. All right, so let's find the theoretical yield. 684 divided by 342.297 times 4 times 46.069 gives us 368.23 grams of ethanol. There is our theoretical yield. Now, a warning bell should be going off in your head. All right, hey, we have a problem, right? The theoretical yield up here is 368. We made, oh wait, never mind. Sorry, there should be no warning bells. We have looked at this, right, and we're saying 368 is greater than 349, so we should be good to go there. So let's figure this out. Our percent yield is the actual, which is 349 grams, divided by 368.23 grams times 100. Getting ahead of myself there. So what I was going to say, if the actual yield is greater than the theoretical yield, then warning bells should go off, right? Something's wrong. You have a dirty product. In this case, we just have a good run, right? Our still out in the mountains is producing our corn liquor well. So 368.23 times 100. So we have a 94.78% yield. That's a good percent yield. Anything above, like anything around 95 or better is a good percent yield. So that's a great percent yield there. All right. Let me change something over here. All right. The last question, we're going to rearrange this a little bit. So we have the same reaction, but now the word problem is a little bit different. So it says if 500 grams of sucrose is fermented and produces an 89% yield, how much ethanol was produced? Okay, so let's look at our percent yield formula. It says percent yield equals AY over TY times 100. So it asks us how much ethanol was produced in the lab if we got an 89% yield. So we know AY, or sorry, we don't know AY this time. We need to find AY. So we just need to rearrange our formula. So we divide 100 by both sides, and we multiply by TY on both sides. And that tells us that AY equals TY times percent yield divided by 100. All right, there we go. So we're going to write that down up here. AY, let's see here. AY equals TY percent yield over 100. All right, so that is the formula that we need in order to get this problem right. So let's erase this, and we'll work our problem. Now, based on that formula, we still need to find theoretical yield. Theoretical yield is a mathematical concept. It's very common for us to need to find that. So let's find it. We've got 500 grams. We're just going to say sugar because we know that sucrose is table sugar now. We know that sucrose is 342.297 grams in a mole. Right, it didn't change from the last time. According to our balanced equation, it takes 1 mole of sugar to make 4 moles of ethanol, and 1 mole of ethanol is 46.069 grams. So let's see what our theoretical yield is. 500 divided by 342.297 times 4 times 46.069 is 269.175 grams of our C2H5OH. All right, so we have theoretical yield. We know the percent yield from the problem, right? It's 89. And so now we just plug it in. So AY equals 269.175 times 89 divided by 100. Now, you could just make that 0.89 and save yourself the trouble, but just so we stick with the formula itself, we will put the whole thing in there. 89 over 100. And the calculator tells us our answer is 239.57 grams, all right, of C2H5OH. There it is. That is the actual yield. There we go. All right, so that's how we use AY and TY and find percent yield. If you have any questions, let me know. I'll be glad to give you a hand. But that's it for this set of practice problems.